So today we're going the third column in our semester 2 review. So we're going to be doing questions 21 through 33. So let's go ahead and take a quick look at question 21. Given the function f of x equals the root of x plus 8, find the domain and the range. So I need to figure out what spans we're allowed to do. And now that does parlay with the questions that we'd done previously, where we had to figure out what questions could we graph. So if I have this question, f of x equals root x plus 8. Now, the domain should be quite simple. We can either identify that this graph has been moved to the left by 8 units. I know typically all values are going to be to the 0 and to the right. If I move them to the left by 8 units, that's negative 8 and to the right. So I could immediately say, hey, I know the domain, which has been moved by the left by 8, is going to be negative 8, comma, infinity, including negative 8 all the way up to infinity. And I could just immediately spit out that answer. The other way is to algebraically calculate it. I know that the square root has to be taken by positive numbers. So what I could do is I could say, let's do this over here, is that x plus 8 must be greater than or equal to 0. And just go ahead and solve for x. Let's subtract 8. X must be greater than or equal to negative 8, which means at the bare minimum, to be equal to negative 8, it has to be negative 8. And anything larger, so negative 7, negative 6, 0, 2, 10, 50 are all greater than or equal to negative 8. So negative 8 all the way up to infinity. Either way, they both lead you to the same value. The second thing that we're going to look at is the signage of this. If I plug in any of these values, let's say negative 8, I get negative 8 plus 8 is 0, square root of 0 is 0. If I plug in negative 7 plus 8 is 1, square root of 1 is 1. So 0, 1, it looks like I'm counting upward. So the range is going to be that minimum value, which is going to be 0 all the way up to infinity. It might take us a while to get to infinity, but we'll get there. The other way, if we don't want to do this by plugging it in numerically, is we could look at the sign. I notice that this is a positive root x plus 8, which means that whatever my starting point is, whatever the pure extreme of my domain, that negative 8, let's plug in that negative 8. So if I plug in the negative 8, I get root of negative 8 plus 8. I get the root of 0, which is 0. 0 upward is going to be 0 all the way to infinity. Either way, I get to that same value. Perfect. So now that we've seen that kind of in action, let's go ahead and try out the next one, number 22. 22. I want to find the domain and the range of this f of x function. 2 root x minus 3. Okay. So depending on how you want to work it, I think the more common method that is going to be working it like this is just by algebraically solving what can I take the root of? Well, x minus 3 must be greater than or equal to 0, which means x must be greater than or equal to 3. If I write that in interval notation, that means that my domain is anything from 3 greater, so from 3 to infinity. The next thing we're going to do is that is a positive 2. So for my range, what I'm going to do is I'm going to plug in that limit of 3 and say, okay, 2 root of 3 minus 3. Well, 3 minus 3 is going to be 0, so 2 root 0, square root of 0 is 0, 0. I know my range is going to be either 0 up or 0 down, depending on the sign. Because that is a positive, I know this is a 0 up because it's positive. So from 0 to infinity. Perfect. Cut my line. 23. Let's take a look at number 23. Again, find the domain and find the range. Root of x plus 1 minus 4. Okay, so for the domain, I am again going to set this into motion and say, okay, I have to take the root of a positive number. So x plus 1 must be greater than or equal to 0, which means x must be greater than or equal to negative 1. So negative 1 is the lowest possible number, and anything above that all the way up to infinity is my domain. Okay. To find the range, I'm going to plug in that extreme domain, and I'm going to say, okay, let's take the root of negative 1 plus 1 minus 4. The root of negative 1 plus 1 is the root of 0. Root of 0 is 0, negative 4. So negative 4 is either going up or down. I'm going to take a look at the sign. Because this is a positive, it is negative 4 on upwards. So the range is from negative 4 all the way up to infinity. Perfect. Let's cut our line. 24. Very similar style question, except for this time, instead of a square root, I have a cube root. So cube root of x plus 4 minus 1. And so this pulls into function. Do we recognize the values of a cube root? What is the shape of a cube root function? Well, I know that square root, if y equals root x, the general function has a starting point and it goes on in one direction. Now we manipulate this, it might be flipped down, it might be flipped backwards, but it has a starting point and it goes in one direction, both in the y-axis and in the x-axis. If we remember that the parent function of a cube root of x, I have no such limitation. That point goes both directions, both positive and negative y and positive and negative x. So there's no domain limitation, no range limitation. So regardless of how this question is set up, what we know is the domain, depending on how you want to write this out, is either all real numbers or negative infinity to positive infinity, however you want to put that. And the range, likewise, because it continues, even though it's much slower, because it's moving mostly in the xward direction, it's still going up. The range is either all real numbers or negative infinity to positive infinity. Perfect. So number 25, remove number 25. See what we're getting? We have a very similar style setup. I have f of x is equal to the cube root of x minus 2 plus 3. I need to find the domain and the range of that. Like we said previously, the shape of this function is going to be, we have a point right here. It looks like a root going up in this direction, but it continues off in that direction. So there is no limit. Domain is either all real numbers or negative infinity to positive infinity. Same thing with the range. The domain is either all real numbers or negative infinity to positive infinity. Do we have enough room for number 26? We're going to pop over to a new sheet of paper for this one. Okay. So number 26. Number 26 is we're solving an equation. So solve for x. So I have 5 root 4x plus 7 equals 30. So this is just solving an algebra problem. We're going to go ahead and try and attack the x by reversing everything we can. Outside the radical, I have a times 5, which means I'm going to go ahead and divide both sides by 5 to leave me with a root of 4x plus 7 is equal to 6. I divided both sides by 5. At this point, to get rid of the radical power, I'm going to go ahead and I'm going to square both the left and the right sides. If I square a square root, it disappears. But if I square the left, I square the right, so 6 squared is going to give me 36. At this point, reverse of order operations, I'm going to do addition, subtraction first. I'm going to subtract 7, and then I'm going to divide by 4. 29 does not divide by 4, so I'm going to leave it just like that. Perfect. That's number 26. Let's take a quick peek at number 27. Okay, number 27. Looks like I have a double radical. So I have the root of 9x minus 3 is equal to the root of 4x plus 12. So there's nothing outside the radical to try and move around. So my first step is to square both the left and the right-hand side. If I square a square root, it cancels out. If I square a square root over here, it also cancels out. Then at this point, I just solve it like I would solve a regular algebra problem. Move all the x's to one side by subtracting 4x. Move all the constants to the other side by adding 3. And then get rid of the coefficient by division, which is going to be x equals 3. Now, the big thing that you do want to pay attention to with some of these is you want to make sure that your answers are eligible. We didn't actually check the first one, but if I try and plug in 29/4 into this, 29/4 of 4 is going to give me 29 plus 7. That is a positive number. That answer is valid. For this one, if I plug in the 3, 3 times 9 is 27, minus 3 is going to be 24. Over here, 4 times 3 is going to be 12, plus 12 is 24. Those are both positive. Those are valid answers. If, for example, I try and plug in my value, and let's say I get a negative square root and a negative square root, it would appear to be a valid answer, but it would actually be an extraneous solution because it would not work when checked on. So keep that in mind. Whenever you see a radical, you always want to try and plug your answer back in. Make sure that does actually check out. Okay. Let's look at number 28. Another solve for x problem. So 2 root 3x plus 1 minus 6 is equal to 12. If we work on this one, I have some things outside the square root, so I'm going to move some things around. So the first thing I'm going to do is I'm going to add the 6. Remember, with PEMDAS, I'm going to work in reverse order when solving an equation. So I'm going to consider these a set of parentheses, which means that addition and subtraction comes first. Add 6 to both sides. Then I'm going to move over to multiplication division, so I'm going to divide each side by 2. Awesome. Now at this point, to get rid of the square root, I square both sides. So if I square this side, 81. If I square this side, 3x plus 1. Then I go back through and reverse PEMDAS. So addition and subtraction, I'm going to subtract that 1. And then divide by 3. X equals 80 divided by 3. And remember, we always go back and we check our answers. So 3 times 83rd is going to be 80, plus 1 is 81. I can take the square root of 81. That checks out. That's 28. If we look at number 29, let's take a peek at that. 29. Okay. 5 cube root of x minus 1 equals negative 10. Okay. So I'm going to treat this radical just like I would treat a square root. I'm going to get rid of anything outside of it first. So I'm going to divide both sides by a 5. So cube root of x minus 1 is negative 2. Now, just like a square root and a square power canceling out, a cube root and a cube power are going to cancel out. So if I cube this, I'll get a negative 8. Negative 2 times negative 2 times negative 2. This will cancel out and leave me with an x minus 1. After that, I add my 1, negative 7. I go ahead and I double check, make sure I can take the cube root. Now, cube roots don't care if they're positive or negative. I can work it. So negative 7 minus 1 is negative 8. The cube root of negative 8 is negative 2. 5 times negative 2 is negative 10. That does check out. Okay. So that is number 29. Let's take a quick peek at the next one, which is going to be number 30. Now, number 30 is a multi-part question. We're using some equations that they gave us with f, g, h, and j. And what we want to do, this is using composition of function rules, is I want to take f of g of 8. Okay? So if I want f of g of 8, well, the first thing I need to know is I need to know what is f and what is g. So I'm going to copy down my f and my g. So f of x is x squared minus 9, and g of x is 1/2 x plus 5. Okay. We know with these functions, I work them from the inside out. So I'm taking 8 and I'm plugging it into, let's do it like this, plugging it into g. Whatever my answer is, I plug that into f. So my first step is take 8 and plug it into g. So let's take g of 8. G of 8 is 1/2 of 8 plus 5. Half of 8 is 4, 9. So g of 8 is 9. And we said we take our answer, whatever g of 8 is, 9, and I plug that into f. So f of g of 8 is saying, what is f of 9? I'm going to take that. That's going to be whatever squared minus 9. What number did we say g of 8 was? 9. So 9 squared is 81. Minus 9 is going to give me 72. So f of 9 is 72, which is saying that f of g of 8 is 72. Boom. So that was number 30. Number 31 is going to be a very similar style question, plugging a function into another function. Okay. So for number 31, let's take a peek at this. I'm taking f of j of 3. Okay, so let's copy down what our f and our j are. Okay, in this case, f is, again, x squared minus 9, and j is x minus 7. Okay. If I look at this and how I'm going to work it, it looks like I'm going to take the 3 and plug it into j. Whatever my answer is, I'm going to plug that into f. So inside out, I'm going to take 3 and plug it into j first. So j of 3. J of x is whatever that is minus 7, 3 minus 7. So j of 3 is negative 4. I take that negative 4 and I plug that into f. So I take that negative 4, which is what j of 3 is, plug it into f. Negative 4 squared is 16. 16 minus 9 is going to give me, let's see, 7. So I plug that in here, and then I evaluate that. And so my f of j of 3 is 7. Boom. There's number 31. Number 32 is a very similar style of question, but I'm not plugging in a number. I'm just plugging in the overall function. So I'm not going to get a whole number answer. I'm going to get a new equation. But it works exactly the same. Let's take a look at 32. Give the expression for f of j of x. Okay, so this is almost exactly what we just did right here, f of j of 3, but instead of plugging in a 3, I'm keeping my original x. So let's copy down our f and our j. So in this case, my f is x squared minus 9, and my j is x minus 7. Okay. So because I have no value to plug into j, I'm just going to take j and plug it into f. So another way to rewrite this is going to take, well, what is j of x? Well, j of x is x minus 7. Why don't I take that and plug that into f? That's easy. Well, f of x is this. Let's plug that into the variable. So x minus 7. So here we go. I have this function. If I FOIL this, this is going to give me an x squared minus 14x plus 49 minus 9. The way that we got this is, if you remember, whenever I square a binomial x minus 7 squared, I have to write this out twice. Many of you will get the x squared and the 49, but you're wondering where the negative 14 came from. Remember, that's x minus 7 times x minus 7, f o I L. First, outer, inner, last. We have to distribute the x to both of these terms and the negative 7 to both of these terms. Negative 7x gives me the negative 14x. So don't forget about that right there. It's a very common mistake made. At this point, we get x squared minus 14x plus 40 because I can combine the plus 49 and minus 9. So my f of j of x gives me that. I don't get a number, but I do get an expression. And conveniently, we can actually check our work right here. I know f of j of 3 is supposed to be 7. If I plugged in a 3 into that, that's 9 minus 3 times 14, which is going to give me, let's see, 30 plus 12 is 42. So negative 42 plus 40 is negative 2. 9 minus 2 is 7. So this does actually check out with our prior work right here. Perfect. So for the last one in this column, number 33. So I have h of g of x. H of g of x. Okay. That means I need to figure out what is h of x. H of x is negative 2x plus 6. G of x is 1/2 x plus 5. Okay. So what we got going on right here is I'm going to take g of x and plug it into h. So another way to write this is, what is h of 1/2 x plus 5? I'm literally taking g of x and plugging it into h. So let's set that up. H of x is negative 2, plug in something, plus 6. What is that something? This right here. Negative 1, not negative 1/2, it's just 1/2 plus 5. So negative 2 times 1/2, negative 1. Negative 2 times 5 is negative 5 halves plus 6. I need to convert this 6 into halves so that I can add these two values together. Well, 6 is just 12 halves. Awesome. So 12 halves minus 5 halves is 7 halves. And so my h of g of x is negative x plus 7/2. And there we go.